All right, so Unit 7.4, similar triangles. This is kind of where everything comes together. So everything from 7.1, 7.2, 7.3 kind of all folds together into this unit. And really, this section is the core of all of Unit 7. So similar triangles, here we go. Okay, so what actually makes two triangles similar? So if you remember, back in semester 1, we talked about congruent triangles. Congruent triangles were the exact same shape and size. They had to have congruent angles and congruent sides. When we're looking at similar triangles, we're going to have 3 pairs of congruent angles. So this angle is going to be congruent to this angle to this one, and this angle to this one. Okay, now what makes a difference, right, is similar is same shape, but not the same size. So thinking to dilations when we made them bigger or smaller, that's how similar triangles plays in, right? So the sides are going to be proportional, meaning they have the same ratio. So if I have sides here that are 1, 2, 3, then this triangle could be 2, 4, 6. And if I look at those corresponding sides, the ratios are the same. So if I look at the bottom sides and I compare those, that's 1 to 2. If I look at the left sides, that's 2 to 4. And then if I look at the right sides, that's 3 to 6. However, all of these, if I simplify them, is really saying 1/2, 1/2, 1/2. So they all have the same ratio. So that's how we know if triangles are similar or not. And again, similar to congruent triangles, when we had shortcuts, we also have shortcuts for similar triangles. So let's get into those. Okay, first one is just angle similarity. This symbol here, you guys are going to see it a lot. That just means similar to. So this one here, you should recognize that means congruent. So it's similar to that, no pun intended, but just the squiggle without the equal sign underneath means similar. So if I write that, that's what I'm saying. Okay, so angle similarity just says if we have 2 angles in one triangle that are congruent to 2 angles of another triangle, then the triangles are similar. So you can see in this picture here, S is congruent to M and R is congruent to L. And so that is enough information to say that triangle SRT is similar to triangle MLP. And also this right here, this is a similarity statement. Again, we talked about these in congruence with congruency statements, and we're going to write them as well with similarity statement. So if it says write a similarity statement, that's what you're writing there. Okay, so first 2 examples, we're just going to look at, are these 2 triangles similar, and if so, how? Okay, so anytime that you're given angles of a triangle, like you are in number 1, you're going to want to find the missing triangle of each, right? So in triangle JKL, I have a 30-degree angle and a 70-degree angle. I know all 3 angles of a triangle have to add up to 180. So if I take 30 plus 70, that's 100 degrees. What's missing? 80 degrees. So that angle at the top there is 80. Okay, now if I look at QRP, I have a 70 and an 85. So again, let's figure out what's missing. If I add those together, I get 155. Subtract that from 180, and this missing angle is 25. Okay, so now if I'm trying to figure out if these are similar, I see one congruent angle, right? There's a 70-degree angle in both. However, this is 30, this is 25, this one's 80, and this one's 85. So there's only one congruent angle in there, and I need 2. So this one would be not similar. Okay, not similar. Because again, we only have 1 pair of congruent angles. We need 2. If we have 2, automatically we know those third angles have to be congruent. That's why it's only 2 that are needed. All right, so let's look at angle or number 2. We have this 45-degree angle. We know those are congruent to each other. They're both 45. I'm looking for another pair of congruent angles to make sure that this is similar or not. Now, nothing else is labeled. However, we've talked about In previous sections, it's come up quite a bit. Anytime we have vertical angles, so these angles formed from an x, those are always going to be congruent. So even though there's no value there, we don't know how much or how many degrees that is, we can say that those are congruent because those are vertical angles and vertical angles are always congruent. Okay, so now I have two pairs of congruent angles, and so that's enough to say that those are similar. So we would say yes, and then this would be angle-angle similarity because again, we have those two pairs of congruent angles. Okay, getting into another similarity shortcut, we have side angle side. So again, just like what we did when we did congruence, I have one side proportional to another side. I have this side proportional to the other side, meaning they have the same ratio. They're not going to be the same. And then I have the angle in between those two that is congruent, okay? So two proportional sides, the angle in between, that's congruent. And if we have that, then we can say that ABC is similar to QRS. So again, two sides, proportional, and the included angle that is congruent. Okay, our third and final shortcut is side, side, side similarity. So again, just like congruence. However, the difference is we're not saying that all three of these sides are equal. I'm saying that these three sides are all proportional, meaning they share the same ratio. Okay, so AB is over QR is going to equal the same as AC over QS, which is going to equal the same as BC over RS. And if that's true, those are similar, and we would use our reason or our rule would be side, side, side. Okay, so let's look at a couple. So this one we have to do a little bit more than we did on the first few examples. Okay, we're going to decide if they're similar, so we're going to circle yes or no. If they are, we're going to figure out why. So that's our rule. Again, rules in this point would be angle, 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 side, or side, side, side. And then if they are similar, we're going to write our similarity statement. If we find that these are not similar, then the second and third part, we put nothing. Okay, so let's look at this. Anytime I have three sides, sometimes it's hard to figure out what corresponds to what. So I know I'm looking at three different ratios. So I'm just going to set that up. And then I'm going to look at my smaller triangle, and I'm just going to go from least to greatest, and those are all going to go on the top. Okay, and then I'm going to do the same thing with my bigger triangle, and I'm going to go least to greatest, but those are going to go on the bottom. Okay, and now I'm going to compare those ratios. So if I look at 6 over 9, if I simplify that, right, those are both divisible by 3. That's really 2/3. Okay, 8 and 12, if I simplify that, those are both divisible by 4. So that's 2/3 too. So far so good because those two are the same. And then 10 over 15, those are both divisible by 5, which again gives us 2/3. Okay, so we would say yes, those are similar because we have three sides that are proportional. So my rule would be side, side, side. And then my similarity statement, I'm going to say STU, triangle STU, is similar to, now, when I wrote this, I need to make sure things correspond, right? Again, so I started at the smallest side and went to the middle side, right? So I started at S, oops, and then I went to T, and then I went to U. So I'm going to do the same thing over here. So I have to go smallest to biggest. So X, we're going to start there, go to V, and then to W. So triangle X, V, W. And that means that those sides correspond, right? So when I'm looking at similarity, I would know that angle S matches angle X, angle T matches angle V, angle U matches angle W. Again, just like we did with congruence. Okay, let's look at another example here. Are the triangles similar? If so, write your similarity statement and give your reason. So again, the three that we're looking at, angle, angle, side, angle, side, 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 side. Okay, well, I'm only given two sides, so it's probably not going to be that one. And I'm not given any angles, right? So at least the two angles is probably out. But what about side, angle, side? So these are overlapping triangles. if I redraw these, right, if I think about that one, that's KPL. So I have a 12, I have an 8. And then if I do the bigger one, that's KMN, right? So this whole side would be 15. This whole side would be 10. But if you notice here, the thing to keep in mind is that in both triangles, we have this angle K. So that is the reflexive property that we talked about before. And those angles are congruent to each other because it's the same angle. So what we're really looking for is 8 over 10 equal to 12 over 15? All right, so again, if we simplify these, 8 and 10 are both divisible by 2, right? So if I do that, I get 4 over 5. And then 12 and 15, those are both divisible by 3. If I do that, I get 4 over 5. So that checks out. We have our congruent angles, so we're going to say yes, those are similar. My rule would be side, angle, side. And then my similarity statement, I'm going to say triangle KLP is similar to triangle KMN. Because again, that's how those sides correspond. K matches K, L matches M, P matches N. More here. Are these triangles similar? If so, write a similarity statement. Okay, so we have 3 sides, so we know right away if this is going to be similar, we're looking at side, side, side. So let's set up our 3 ratios. I'm going to start with my small one, and I'm going to go least to greatest, so 22, 30, and 40. And then I'm going to do my bigger triangle, and again, least to greatest, so 32, 45, and 60. All right, and then let's simplify these. 22 and 32 are both divisible by 2, so that makes that 11 over 16. 30 and 45 are both divisible by 15, so that makes that, not 15. I'm dividing by 15, so that would be 2 over 3. Okay, so automatically, or not automatically, but right away, we don't even have to look at what this third one is because these two ratios are not the same, which means that no, these are not similar. And if we're hitting no, they're not similar, then we're not putting a rule, we're not putting a similarity statement. As soon as we decide no, it doesn't work, okay, the rule is saying yes, it does work, right? So if we put no, it doesn't make sense to write a rule and it doesn't make sense to write a similarity statement. Okay, so there's seeing your rules in action. All right, so then last thing is, how do we use similar triangles? Okay, if we know that these triangles are similar, we can use them to find for missing variables. So this is saying if the triangles are similar, so we're going to assume that they are. Find the missing variables. So we're just going to set up a ratio for each, so a proportion, just like we did when we were solving proportions in Unit 7.1, right? But now it applies to a specific situation, and we see these similar triangles. So I'm going to look at my small triangle first, and I'm going to put 90 over 120. And then I'm going to look at my big triangle, and this 90 corresponds with this 135. So the 135 is going to go on the top. The X is going to go on the bottom because that corresponds with the 120. And from there, I am just going to cross multiply, again, like we did back in 7.1. So I get 90x equals 120 times 135, which is 16,200. Divide both sides by 90, and you get x equals 180. So it is 180 feet across that lake. Okay, that's where these similar triangles come in handy. Okay, because it had a picture given to you, so it was easy to set up. Now this one, it's just words, so we're going to have to decipher a little bit here. So a 2-foot vertical post casts a 1.5-foot shadow. At the same time, a nearby cell phone tower casts a 120-foot shadow. How tall is the cell phone tower? So we're comparing two things here. We're comparing the height of the towers, and we're comparing the length of the shadows. Okay, so that's the biggest thing is figuring out what two variables we have. Okay. And so we have a post that is 2 feet tall. So that's the height and has a 1.5 foot shadow, right? So height on the top, shadow on the bottom. Now, the cell phone tower, we only know that it casts a 120-foot shadow. We want to find the height. Okay, so the shadow goes on the bottom, that's 120. And how tall is it? That's what we're looking for, so that's where we're going to put our X. If you want to try and draw a picture, you can. So I have a post that is 2 feet tall, 1.5 foot shadow, right? It makes a triangle. I can do the same thing with the cell tower. We don't know how tall it is, but we know it casts a 120-foot shadow. Drawing a picture like that might help you. If you're a visual learner, it might help you see what your proportion is going to look like. So feel free to draw a picture for any of these that don't have one included in their description. Okay, so again, we're just going to cross multiply. 2 times 120 is 240. And then equals 1.5 times x. Divide both sides by 1.5. And you should get 160 equals x. Okay, so there is your answer. The cell phone tower is 160 feet tall. Okay, so that is 7-4. Like I said, it's a lot. It's kind of putting everything together. So take your time with this video, go back and rewatch it a couple times if you need to, and then we will do some more practice with this in class.